This is the 9th video on this introduction to robot design in VEX parts, and we left off, we started to talk about mechanism wheels, and they're pretty strange looking wheels, and you can see that one of the things you can do with them, if you rotate them in opposite directions like this is shown right here, then you can actually move sideways like a crab. So here's a little video that gives you some idea of the way that you can move with quite a lot of flexibility in the way that you would move around. But it's it's more complicated, of course, to program, and it takes more power to run them than there's a lot of slipping, sliding on with these types of wheels, so it does take more torque to to move around. But if being able to move sideways and have that flexibility as a premium, then it might be worth putting that in your design. So next we'll talk about gears, and there's different size gears. These pinions are 12 tooth, and you also have different strength gears. So so as with the other VEX parts that are you have these available set files which you can put into solid modelers. So this is the regular standard gear. This is a excuse me, the 36 tooth standard gear. It has the 1/8 inch square hole. It has a face width, which is the distance across here. That distance is 1/4 of an inch on these standard gears. And on the high strength gears, now you're going to, instead of using an 1/8 inch square shaft, you use a 1/4 inch square shaft, right? And you can see it also has these extra holes so you can bolt it to something. And the face width across here, in fact, maybe I can just show you this. If I click with a solid model, if I click on that and hold down the control key and click over here, down the bottom of the screen, you can see 0.5 inches. So that tells me the distance from between those two surfaces. Whereas over on this one, if I click over there and over here, now you can see that distance is 0.25, 1/4 of an inch. So anyways, you can see the difference between, they're actually the same size in terms of the number of teeth, and but this one has twice the face width, so theoretically then it can carry twice as much load before it breaks, right? And it has a 1/4 inch shaft hole instead of an 1/8 inch shaft hole. So those gears that we were just looking at were 36 tooth gears. This is an 84 tooth gear. So you can see that, right, if you were to mate this with a 12 tooth sprocket, 12th tooth sprocket, and the big gear is 84 tooth, and that would be a ratio of 7:1. So the pinion would have to turn 7 times to get the 84 tooth to turn once. And if there was no friction, of course you're always going to have at least some friction, but then you would have 7 times the torque, less whatever the friction uses up. So that way you can get a lot more torque. And notice that this has a lot of mounting holes, so that if you were trying to move an arm with this, instead of just connecting to the arm with a 1/8 inch shaft, you could actually put some standoffs in and bolt the arm to the side of the gear, and that would make it a lot stronger. In addition to the gears, you can also, VEX also has various size sprockets and chain that you can use. They also have pneumatics available, so you can use compressed air. Obviously you have to have some kind of storage tank for the compressed air or some type of compressor, and piston cylinder devices, and then a variety of valves so that you can open and close, or extend or retract the shaft on the cylinder. They also make these rubber fingered intake rollers, which are sometimes useful for gathering balls if that's part of the competition. And I'm going to have to stop here and pick up with the next video.